with her presentation. The floor is yours.
Thank you. Today we will talk about the difference of glottal sounds present in Korebaju. This research is made together with my doctoral thesis director, Nathalie Vallée, who's right now in France. So we will begin with a brief introduction of the Korebaju community and the language, and then we will discuss the objective of this research, and then we will continue with the method used in order to discuss the results obtained, and then we will end with some relevant discussions and conclusions. So the Korebaju community lives in the foothills of the Amazons in southwest of Colombia. This community has approximately 2,000 people distributed in 27 Amerindian reserves, where they all speak the language. Today, Korebaju community is the result of the union of 4 different communities: Macaguaje, Korebaju, Tama, and Carijona. In this way, 4 dialectical variations has been tested. Our study was carried out only with speakers of the Korebaju variant. The Korebaju language is a tonal language belonging to the Tucanoan family, more exactly to the Western Tucanoan branch, along with languages such as Queretu, Maihuki, Siona, and Secoya. Previous studies in Korebaju refers to glottalization in 3 different manners: as a phonological process that produces a vowel lagging when it disappears, as a phonological glottal stop occurring in syllable coda position, and as a suprasegmental that represents either an onset or a compensation of long vowel elision. As well, 3 different analyses about glottalization has been done in another Tucanoan languages. An analysis for Tucano and Eastern Tucanoan language has proposed that the glottalization is part of the vowel and plays a contrastive role in its phonetic levels. However, the author did not provide any phonetic description or analysis. Other studies have suggested that the glottal stop is a phoneme in the language, such as Piratapullo, Desano, Secoya, etc. And it occurred either in coda or onset of the syllable. Finally, an autosegmental feature that calls constricted glottis, which is present only in radical morphemes after a vowel carry a low tone, has been present in other languages as Guanano, Piratapullo, Tucano, and Desano, in which this suprasegmental may be occurring in coda, in just coda position of the root morphemes. The aim of this study is to clarify the phonological status of Korebaju glottal sounds, as well as to identify and describe their allophones and infunctions by considering the general theory of the language and the different glottal mechanisms. In this way, we will describe and analyze 4 different glottal sounds found in the language. So the glottal vowels, the glottal stop, the creaky voiced glottal approximant, and a presumed glottalization of the set of nasal consonants of the language. So for this, 6 native speakers, 2 female and 3 male, were involved in this study, considering the fact that recent social evolution can have impact in Korebaju. 2 different generations were chosen for this experiment, a first generation between 23 and 29 years old, and a second generation between 47 and 59 years old. No speaker has left the community for more than 2 weeks at the time the recordings took place. A Zoom recorder has been used to unregister the speakers, along with a short cardioid headband microphone was placed in a distance of 2 fingers from the mouth of the speaker, in synchronization with an electroglottograph. Both units were connected to a sound card. 2 solar panels belong to the community, has been the power source for this research. Record is made in an enclosed area and in certain times to avoid like the forest sounds, such as bird songs or animal sounds. Audacity software was used during the audio and electroglottograph recording. A data quality check was carried out in the field using Pratt software. Pratt software were also used for data analysis. Different figures of the acoustic signal, electroglottograph, and spectrogram were extracted using Pratt's figure script. For this study, 3 different recordings were made, 2 audio and 1 in synchronizations with an electroglottograph. A list of 2,075 words in a carrier sentence were recorded, and the construction of this list made it possible to be systematic in the identification of minimal and quasi-minimal pairs in all possible contexts among the 6 speakers. A difference at the level of the 6 morpheme has been found during the production of the sentence. However, this morpheme is attached to the verbal root and therefore does not affect the production context of the keyword. A previous study made by us found a contrast between a set of 3 non-high vowels, A, E, O, and their corresponding glottal vowel. The present investigation extends the finding and shows that the glottal vowel occurs in first, second of the word roots and in some suffixes as well. The spectral analysis of the vowel shows a clear glottal constriction at the end of the voiced part. In most cases, the vowel carries a low tone, but not all the time. According to our previous study, the duration of the glottal and modal vowels is equitable. The figure shows a clear decrease in the amplitude of the acoustic and electroglottograph signal. The electroglottograph signal and the spectrogram show that there is no creaky voice or a laryngization, but rather a glottal constriction in the final part of the vowel that is similar as a glottal stop. Also, we found a no constructive glottalization in a high oral and nasal vowels. They appears in an interconsonantical context with a condition that the consonant which follows the vowels is an unvoiced stop. These productions are not systematic among the speakers. Inter and intra-speakers variation are attested for this type of productions, regardless their age, gender, vowel type, or pitch couture. However, they occur only in the first syllable of the roots. We did not find minimal or quasi-minimal pairs that can support their phonemic status. A creaky voice glottal approximant and a glottal stop were found in intervocalic context. This production occurs randomly among the speakers regardless of age or gender. And their purpose begins to mark a syllable onset and fill an empty onset as well. These sounds can also appear between morphemes. However, we failed to find contrastive context for these sounds. According to previous studies done in Wanano and other Tucanoan language, they are considered to be realized with a constricted glottis, which is a suprasegmental feature that aims to mark a syllable onset. In Korebaju, these productions are found in root and affixes morphemes, and this finding is different from what has been found and has been observed in Wanano, in which this sound is only part of the radical morphemes. The glottal productions are usually, but not all the times, preceded by a low tone, followed by a high tone. It should be noted that the glottal productions is not present in the whole words of the CVV syllable type. It exists words without this glottalization between these two vowels. This production seems to be not contrastive in the language. The creaky voice glottal approximant is characterized by a regularity of glottal time intervals, as well by lowering of the total closure of the glottis in the acoustic and electroglottograph signals. The glottal stop is characterized by a total closure of the glottis, producing an interruption of the F0. No contrast was found between the glottal stop and the creaky voice glottal approximant in Korebaju. Both glottal productions can occur randomly between the speakers, and we see as we see on the table. This study did not find specific patterns for the production or choice of these two sounds among the speakers. So this study also documents the realization of nasal consonants with final explosion, like a burst. These realizations were found in many contexts, where initial intervocalic position preceded and followed by oral, nasal, glottal vowels. The figures show a systematic production in this, of these birds in the masculine singular morpheme and in feminine singular morpheme as well. This noise or birds is not part of the canonical production of the nasal consonants, which are characterized by a progressive increase in amplitude of the signal to reach the beginning of the vowel that follows without this explosion that we see on the screen. An acoustic analysis showed that this burst at the end of the nasal consonant is not due to a glottal constriction, since the electroglottograph signal is continuous and without any change. We hypothesize that the source of this explosion is a glottalic aggressive airstream produced by a rise of the larynx, created a rapid release of the oral closure and an abrupt release of the acoustical pressure. However, in this case, it will have been expected that the rise of the intraoral pressure contributes to push the balloon upwards and helps it to rise and to close the baropharyngeal port. Unfortunately, this study cannot test this hypothesis. A more precise analysis of articulatory phonetics will make it possible to know more about this source of burst. This study has been analyzed a set of 3 phonological glottal vowels, 4 glottal vowel sounds as well. 2 orals and 2 nasals were found in interconsonantical contexts on the condition that the following consonant is an unvoiced stop. 2 consonants sounds, the creak, voiced glottal approximant, and the glottal stop, were found in intervocalic position, and that marks its syllable onset. And finally, we refuse the glottalization of the set of nasal consonants. We hypothesize that the burst indicates of the glottalic aggressive airstream produced by the rise of the larynx, as we said before. We are currently focusing our study on the relationship between glottalization, nasalization, and tonal system of the language. Those extending our study into 2 different dialectical variations, Korebaju and Tama, where a change in the glottal productions were found. This study is done by considering studies in the other 2 canonical languages, but also in the proto-canonical languages, employing a new electroglottograph that synchronizes recording audio, aerodynamic, and electroglottograph signals together with a large tracking system. So thank you very much, and that's it.
Thank you very much for the presentation. So are there any questions?
Thank you. That was really interesting. You mentioned really just in passing that the glottal vowels were often associated with a low tone, but not always. I was wondering if you could say a little bit more about the relationship between glottalized vowels and tone.
Yeah, actually, in the other 2 canonical languages, they have been found that this glottalization has been always found before a low tone. However, like in 2 languages now, Wanano from the Eastern Tucanoan branch and now Korebaju, the percentage is pretty low. It's like 10–20% of the whole words that we record. But we found this case. We found the case where this glottalization can be present between 2 high tones, for example, or 2 high-low tones. So this is undergoing investigation right now because we have to double check also the So as I say, is that. And yes, as I say, so now that's why we are like double check the tonal system of the language, because it's not that clear as we thought. So that's why we are like double check now everything once again and the relationship between.
Great. Thank you.
Thanks.